Okay, welcome to the second half of part two of this lecture where we discuss the general concept of stoichiometry. We looked at our definition of stoichiometry as being looking at a quantitative process where mole amounts of different substances are determined in a chemical reaction. And we discussed in the first half of this topic where this idea of mole amounts come from, or what kind of information about mole amounts could be given by looking directly at our chemical reaction, where we saw that in a chemical reaction, what we get are our mole relationships or mole ratios of each substance that is either used or formed in that reaction. And that comes from our balanced chemical equation, specifically those coefficients in our balanced chemical equation. So that gives us our recipe. Tells us what ratio of each thing is needed in order to come together for the reaction to proceed. But if we are doing a full analysis of stoichiometry or mole counting, then we also need to consider where our quantities of substances come from in moles based on what we're actually doing in the lab. So the second half of answering this question of where do our mole quantities come from is, yes, we get mole relationships from the chemical equation, but also mole quantities come from what you actually use for the reaction to happen in a lab environment. In other words, these mole quantities come from measured quantities of substances. So let's think about different measurements that we could take that are like quantities or amounts of substances in the lab. So for example, this is something like mass, right? If I know the mass of sodium chloride, then I could find the moles of sodium chloride via molar mass. Same deal with volume. If I were looking at a particular volume of pure water, I could figure out the moles based on the density and then the molar mass. We have spent extensive time talking about aqueous reactions. So another way to get these mole quantities or measured quantities of substances is by thinking about concentration. Of solutions, and so on. So let's think about how we might use all of these to get to moles of a substance used or made in reaction performed that's in the lab. Okay, so let's look at mass. So if I have the mass of a substance in grams, and I want to get to the moles of my substance, then I need to divide by my molar mass of whatever my substance is. Okay, what about volume? So I'm going to say, how about a volume in milliliters? It's kind of the volume unit we're most familiar with using in a lab situation. So if I were to take my volume in milliliters, I could first get that into a mass of my liquid in grams using my density, specifically dividing by density. Nope, multiplying by density. And then once we have our mass of our liquid, we could put that into moles by again using molar mass, where we divide by our molar mass. So all I'm doing here is I'm showing different ways that we can get our lab quantities and convert them into moles. Okay, this last one, concentration. As I stated earlier, this is one that we use a fair amount and we'll be using quite a bit in particular for our aqueous stoichiometry. So let's remember, if we have a concentration of something, so let's say that I've got a concentration in molarity, which recall is moles per liter. Then if I want to obtain moles, then I better take my molarity and multiply by my volume of solution in liters. I can also think about this kind of in the inverse way. If I have a volume of solution instead of a volume of pure substance, let's say in milliliters, I would first need to, let's see here, I'm going to move this up here. No, I'm not. All right, so if I have a volume of solution in milliliters, if I'm going to utilize concentration, then I had better first get this into liters of solution. Using the fact that 1 liter is 1,000 milliliters. And then if I want to take this volume and get it into a mole quantity, then I need to take my volume and multiply again. Now, instead of solution volume, multiply by my molarity, or my concentration. So again, this is me illustrating methods that we have available to us in order to determine the amount of moles of a substance that we are actually reacting in a lab environment. So I call this the pantry, because in our pantry, we have lots of varied amounts of each ingredient. So for example, if I wanted to make myself some scrambled eggs, and let's say I wanted to make it for myself and my spouse, then I would need to use more eggs than are given in my recipe. So my recipe, I believe I said, was a 2-egg scramble. So for 2 people, this would mean that I need to get 4 eggs from my pantry. I would need to get 2 pats of butter, and I would need 2 teaspoons of salt and 2 teaspoons of pepper. Another example to liken what's going on in stoichiometry to this kind of cooking or baking analogy of the recipe, which is our equation and mole ratios, versus the pantry, which is our actual lab quantities, then we might think about baking. So I don't know about you guys, but sometimes I get this random kind of whim to bake some cookies, like stress baking. It's a soothing thing for me. And often when I do this, I'm probably at my parents' house because my parents are guaranteed to have everything that's needed to make cookies. Like my dad just kind of always has anything under the sun stocked in his pantry. So if I wanted to bake cookies, I might first look in my pantry. So let's say that I looked in my dad's pantry and I found that he had 1 pound of flour. Let's see here, my dad also had 1 box of baking soda. My dad had 1 pound of sugar. My dad had 4 sticks of butter. My dad had also, let's say, I don't know, 1 box of sea salt. And my dad had 1 bag of chocolate chips. And then also 1 bottle of vanilla. So my dad has a bunch of stuff, as I said. Now, realistically, if I'm thinking about actually baking cookies, I know that I'm not going to just throw the entire bag of flour in with the entire box of baking soda, with the entire bag of sugar, and all 4 sticks of butter, with the whole box of salt, whole bag of chocolate chips, and the entire bottle of vanilla, because we understand from our baking experience that if I were to put everything together in a 1 to 1 to 1 to 1 to 1 to 1 ratio, that this is not how I would make cookies. So what I would probably do second is I would consult my recipe. Okay, I am making up off the top of my head a cookie recipe. I do not recommend trying this recipe. It is something that I am making up, but bear with me here. All right, so let's say that the recipe says in order to make a dozen cookies, then the minimum ratio of ingredients that I need to make 12 cookies is something like the following. So I would need, let's say, 2 cups of flour. I would need 2 teaspoons of baking soda. I would need 1.5 cups of sugar. I would need, actually, if I'm recalling, I think it's 3 cups flour. I would need 2 sticks of butter. I would need 1 teaspoon of salt. I would need 1.5, no, 1 cup of chocolate chips. And then I would need 1 teaspoon of vanilla, but I always add extra vanilla, so I'm gonna write 2 teaspoons of vanilla. So this is what I have available in order to react, right? What I have available in order to bake. And this is what proportion that is needed at minimum to create some amount of cookies. So then when we perform stoichiometry, what we are doing in our stoichiometry is we would be figuring out how many cookies can I make knowing the recipe and given my pantry. So let's say I didn't want to just make 12 cookies, but I wanted to see the maximum amount of cookies I could make. Let's say I wanted to use as much of what my dad has as possible to make as many cookies as I could. Let's say I'm super stressed. So stoichiometry would be the process of looking at our quantities in our pantry, converting them into what we have available, so that we could use our ratios to figure out what that would mean we would need of each. So if I've got 1 pound of flour, how many cups would that be? And then how much would I need to react with how much of my baking soda box, etc. And it's through understanding this lab quantity and mole ratio that we are ultimately going to perform the process of quantifying amounts in a chemical reaction, which is what we call stoichiometry. So this was our intro to stoichiometry. And up next, in order to kind of round out this conversation of stoichiometry, we need to discuss something called limiting reactants. So we're going to talk about limiting reactants in our next video, section 3 of our lecture for Friday, April 7th.